This is section 9.6, where we are factoring polynomials or quadratics of the form ax squared plus bx plus c, and all that means is that the coefficient of the x squared term is going to be greater than 1. I'm going to show you 3 different ways to do it, and it's totally up to you which way makes the most sense. So the first way, the most basic, is just sort of guess and check. So notice that we can't just think about the factors of 4 because we also have to worry about the 3 here. So what we can do is say, okay, factors of 3, there's actually only 3 times 1. So we know it's going to be a 3t plus something times a 1t plus something. And then for the 4, we actually have 2 options. It could either be 4 times 1, or it could be 2 times 2. So we have to figure out which one will give us 8. So since 2 and 2 aren't different, let's see, 3 times 2 plus 2 times 1, 3 times 2 is 6, plus 2 is 8. So that is going to be it, actually. If I had guessed wrong on the first try, I could do, 3 times 4 plus 1 times 1. Well, 3 times 4 is 12, plus 1 is 13, so that's not it. Or it also could be 3 times 1 plus 1 times 4. Well, 3 times 1 is 3, plus 4 is 7, so that's not it either. But I did guess right on the first try, so it is 3t plus 2 times t plus 2. But remember, I can always FOIL it back out to make sure, and I get 3t squared plus 2t plus 6t, which is 8t plus 4. So that's the first method. The second method is called slide and divide. So what you're going to do is slide a, so the coefficient of the x squared, remember I have ax squared plus bx plus c, slide a, then divide both numbers, and then bottoms up. So you'll see what that means in just a second. First thing you're going to do is slide. So I'm going to take this 7, and I'm going to slide it over to the 4. 7 times 4 is 28. So now I'm left with x squared plus 29x plus 28. And now it becomes a problem just like the last section. So 28 can be factored into 4 and 7, or 28 and 1. So I can make my little diagram. What are factors of 28 that when added together give us 29? Well, 28 and 1. So that tells me x plus 28 times x plus 1. But now I have to make up for the fact that I moved the 7. So now I'm going to have to divide both numbers by 7. Okay, and I'm left with x plus 4 times x plus 1/7. But we do not like our binomials to have fractions. So all you're going to do is take the bottom and move it up to the coefficient of the x. That's why we say bottoms up. So your final answer should be x plus 4 times 7x plus 1. And now again, I should multiply it back out just to make sure. 7x times x does become 7x squared, plus 28x plus 1x is plus 29x, and then 4 times 1 is 4. So I know that it's correct. So slide the coefficient of the x squared divide both numbers, and then bottoms up. Alright, the last method is the box method, and it's just like undoing what you do when you use the box to multiply binomials. So what ends up happening is if you use your x, you take the first term, the ax squared term, and the c, and you multiply them. So 6x squared times 5 is 30x squared. That is going to go in the top part of the v. Then you take the middle term, and that goes in the bottom part of the v. And now you're just looking for two terms that when multiplied together give you the top part of the v, so multiplication up there, and when added together give you the bottom part of the v. And then they just go in the two parts of the box that we haven't filled in yet. And then you're just reversing that. And you're essentially looking for what were those factors from the binomial, the terms that got written on the box to begin with. And to do that, you look for the GCF of each pair. So you're just thinking, I got to fill in all these directions. 10x and 5, their greatest common factor is 5. 6x squared and 10x, their greatest common factor is going to be a 2x. And 3x and 6x squared, the greatest common factor of those two is 3x. And the greatest common factor of 3x and 5 is 1. So then that tells us we have 3x plus 5 times 2x plus 1. So we'll try a second one. We have 3x squared plus 16x plus 21. Remember, my 3x squared and my 21 go there. Then I multiply them together to get the top of this box. So that's 63x squared. And then my middle term goes down here, 16x. And then I'm just trying to figure out what two terms, when multiplied together, give you 16x squared. Sorry. When multiplied together, give you 63x squared, and when added together, give you 16x. Well, the easiest way to think about this, you're just going to have two terms with x, but we're trying to figure out what those number coefficients are. So think about the factors of 63. The first one that comes to mind is not 21 and 3, but is 9 and 7. Well, let's try it. 9x and 7x. 9x times 7x is 63x squared. And 9x plus 7x is 16x. 9 plus 7 is 16. So then I write them over here. And then I'm looking for the GCF. So first off, I have 21 and 7x. Their greatest common factor is going to be a 7. 9x and 3x squared, well, their greatest common factor is going to be a 3x. Then 7x and 3x squared, their greatest common factor is going to be an x. And 21 and 9x, their greatest common factor is a 3. So now I'm left with 3x plus 7 times x plus 3. And again, just to make sure, I should multiply it back out. 3x times x is 3x squared, plus 9x plus 7x is plus 16x plus 21. So I know that's right. So any of the three methods, whatever works best for you, is fine. I would say give each of them a try before you decide. But again, totally up to you. And that is it for this section.